Hey guys, Mr. King here. Today we're going to talk a little bit more about that periodic table of elements. At this point, you should know how to read the periodic table of elements. You should know how to look at an individual periodic block and look at it and read that atomic number and know that that tells you the number of protons and electrons, and you should be able to read the atomic mass down at the bottom and learn how to round that and subtract the protons to get the neutrons. So you should have some pretty good idea about what the information on that block means. Now today we're going to talk about how the entire periodic table of elements is organized. And it's classified according to their characteristics and what they have in common and things like that. Here's a little video to start us out. We're going to look at They Might Be Giants again.
Are full of helium, and so is every star. Stars are mostly hydrogen, which may someday fuel your car. Iron is a metal, you see it every day. Oxygen eventually will make it rust away. Carbon in its ordinary form is coal. Crush it together and diamonds are born. Come on and meet the elements. May I introduce you to our friends, the elements? Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Neon's a gas that lights up the sign for a piece of place. The coins that you pay with are copper, nickel, and zinc. Silicon and oxygen make concrete, bricks, and glass. Now add some gold and silver for some pizza place class. Come on and meet the elements. I think you should check out the ones that call the elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Team up with other elements, making compounds when they combine, or make up a simple element formed out of atoms of the one kind. Balloons are full of helium, and so is every star. Stars are mostly hydrogen, which may someday fuel your car. Hey, we're letting all these elephants. Did you know that elephants are made of elements? Elephants are mostly made of 4 elements, and every living thing is mostly made of 4 elements. Plants, bugs, birds, fish, bacteria, and man are mostly carbon, hydrogen, nitrogen, and oxygen. Come on and meet the elements. You and I are complicated, but we're made of elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are. Team up with other elements, making compounds when they combine, or make up a simple element formed out of atoms of the one kind. Come on and meet the elements. Check out the ones that call the elements. Like a box of paints that are mixed to make every shade. They either combine to make a chemical compound or stand alone as they are.
Alright, so you can see there the elements by themselves, you know a lot of those, but when they combine, we get different things called compounds, and we're going to talk about those a little later. So when we look at the periodic table, they're classified by 3 groups, and they're classified by their similar characteristics. We have metals, non-metals, and then we have a group called metalloids, and we're going to talk about each one of these groups today. So on the periodic table, you can see the darker blue, like a royal blue, that is by far the most. the most elements. And then over on the far right hand side, you get like a teal or a turquoise. That's the second most. And then in the middle, you have what are called metalloids. And those, there's not a ton of those. And those down on the bottom, where it says like LACEPR, those are all the man-made elements. And so those are the synthetic ones that we've talked about. So let's start out by talking about metals. Most of the elements are metals. Okay, like I just said, those are the royal blue colored up here. You can see there's quite a few of them. Metals are pretty easy to spot. They have a shiny luster. They're good conductors of heat and electricity. So if you have ever heard your parents say, don't take a fork and stick it in a light socket, that's why. It's made out of metal, and that electricity will zap right through the fork and into your hand. Now, if you did it with a non-metal, like a plastic fork, you wouldn't get zapped as bad. Now, don't try this. Don't tell your parents Mr. King said stick a plastic fork in a light socket. That's a very bad idea. But it wouldn't conduct as much electricity, so it wouldn't zap you. For electricity to run through the computer that you're watching this on, or the TV that you're watching it on, those wires are made out of a metal. Okay, those are made out of copper, and that allows the electricity to go right through it. Metals are mostly solids at room temperature. If you look around your room and you see anything that's shiny, that would be in the solid state of matter. Mercury is the exception. Mercury is a liquid at room temperature. That's a metal that is not a solid. Metals are malleable. We've talked about this. They can be shaped. You can pound them, and they still keep their structure. They don't explode into a million pieces. And they're also ductile. They can be drawn into wires without breaking, which is great. Like we talked about, copper being a wonderful conductor of electricity. So if you looked inside your TV cord, if you could slice that open, you would see a lot of copper wires. That allows the electricity to run through it very, very quickly. Second group that we're going to talk about is nonmetals, and these are found on the right side of the periodic table. And if we go back to the periodic table, you can see these are the turquoise ones, kind of the light blue, over with the He on the top for helium and carbon and nitrogen and oxygen. All those are the nonmetals. And nonmetals are usually dull in appearance. They're not shiny. They're poor conductors of heat and electricity, like I talked about. If you have a plastic fork of some sort, that's a poor conductor. If oxygen, as one of our nonmetals, is a pretty poor conductor of electricity, so you don't shock someone and it travels through the air and it gets someone else. Many gases are gases at room temperature. Many of the nonmetals are gases at room temperature. 10 of them are going to be gases, 5 are going to be solids, and only 1 is going to be a liquid, and that's bromine is the one liquid, the one nonmetal that's a liquid. They're brittle. They can't change shape without breaking. This is different than being malleable. You pound on a nonmetal, it's going to explode and not really do what it's supposed to. And 97% of the human body is made up of nonmetals. Now you might be saying, oh man, you got 3% of metal in your body. Yeah, metals are metalloids. We do have some metal in our body. You have a lot of iron running through your blood, and iron's definitely a metal. And so most of us, though, is made up of nonmetals. You saw in the video, they talked about how 4 elements make up most things in the living things in the world, and that's carbon, hydrogen, nitrogen, and oxygen. And that's true. That's what most things are all made of. So we got the metals, we got nonmetals, and then we got these things that are kind of in between them. They're called metalloids. And the metalloids are sort of like a metal and sort of like a nonmetal. And if you look on the periodic table, that's that kind of grayish group down there between the two blues. You got the B for boron and the Si for silicon. These are things that are kind of like a metal and kind of like a nonmetal. They're found between the metals and nonmetals on the periodic table. They have characteristics of both metals and nonmetals. They do not conduct heat and electricity as well as metals, but they do conduct heat and electricity better than a nonmetal. Because they're metalloids, they are sort of like a metal. So since they're kind of like a metal, they are able to conduct heat and electricity a little bit. They definitely don't do as good as a pure metal, but they can conduct it a little bit. And then all are solids at room temperature. Which makes them kind of different from the others where we had a variety of solid, liquid, and gas for the nonmetals, and then we had solids and liquids for the metals. All the metalloids are going to be solids. So we've got the 3 main categories. We have metalloids, nonmetals, and the metals, and you can see them on the periodic table of elements here. And that's just how it's broken down. We've got the three groups, and it's by their characteristics. So that's how they're sorted. So we've learned that on the periodic block, they're also in numerical order by their number of protons, which we call the atomic number. So not only do they have that in common, they also are classified by their characteristics on whether they're a metal, a non-metal, or a metalloid. All right, guys, write some good questions tonight, but lots to think about, lots of good questions, discussion questions about what could happen to different elements if you put them in different states of matter, or if we found different elements, how would you place them on the periodic table? So think about some good things tonight. Good luck on the quiz, and I will see you guys all tomorrow.